This is a Newton's cradle. It's a classic desktop toy that we all know and we all love. And we've all wondered in astonishment how it just keeps bouncing back and forth. Well, this concept is the conservation of momentum. Before we begin, let's discuss what momentum is. Momentum is the product of an object's mass and velocity. In simpler terms, it is a measure of how difficult it is to stop an object that is moving. The formula for momentum is P equals m times v, where P is your momentum, m is your mass, and v is velocity. The law of conservation of momentum states that the total momentum of an isolated system remains constant if there are no external forces acting on it. This means that if two objects collide in an isolated system, the total momentum before the collision is equal to the total momentum after the collision. So now that we know what momentum is, let's go to Newton's cradle. This is a smaller Newton's cradle, and this is a large Newton's cradle. So here we have the same thing that we had earlier, just a smaller one, but this is on a bigger form factor. As we take these, and let's discuss how it actually works and what the conservation of momentum does when it's doing this Newton's cradle. The way a Newton's cradle works is you pick up one side, and you see when you pick it up to about here, right? About the thing of this, you see that that one goes to the exact same spot. But you see that if you slow it down, let's say we take two of them. Two of them over there are going to do it. And so no matter how many that you do, it's going to keep the same momentum. It's going to conserve its momentum. Even if we do three, you might wonder, how would three work? Well, you take the three, you let go. It still does three despite there only being five. Even there doesn't have to be a middle ball for it to just conserve like that. It conserves its momentum. So let's analyze the math behind the Newton's cradle. So when the first ball is lifted and released, it gains potential energy due to its height. And as it falls, this potential energy is converted to kinetic energy. When it collides with the second ball, its momentum is transferred to the second ball. This momentum is conserved as the second ball gains the same momentum as the first ball had before the collision. This transfer of momentum continues along the row until the last ball swings out with the same momentum as the first ball had initially. Now, let's relate this concept to a major idea in physics. The law of conservation of momentum is used in many areas of physics, including in collisions and explosions. By understanding this law, we can predict the outcomes of these events and design machines and tools that use them to our advantage. For example, airbags in cars use the conservation of momentum to protect passengers during a collision. In conclusion, the conservation of momentum is a fundamental concept in physics that is used to predict the outcome of collisions and explosions once again. Newton's cradle is a simple and fun demonstration of this concept, which highlights that the total momentum in an isolated system remains constant.